It's my great pleasure. Again, many great speakers today, but it is my great pleasure to introduce Nihar Shah. He is an assistant professor at Carnegie Mellon University in the Machine Learning and Computer Science departments. He works in the areas of machine learning, statistics, information theory, and game theory. Importantly, his current work addresses various biases and other challenges in human evaluations via principle and practical approaches. He focuses on applications of scientific peer review, where his work has already made significant impact in multiple conferences. So please join me in welcoming Nihar. Nihar, please go ahead.
Thank you so much, Daniel. Thank you for the invitation to the summer school. This looks fantastic, and I'm really looking forward to interacting with all the amazing participants. I'm going to talk about research on peer review that we do in our group today. And throughout the talk, let's make it informal. Please just interrupt and ask questions. So, you can feel free to type your question on chat, raise your hand, or just unmute yourself and shout out your question. Okay, but please keep asking questions. Like, it's okay if we don't get to the end of the talk. It's important to make it interactive, so do ask questions. All right, so in our group, we work on problems in peer review, where we design algorithmic or computational solutions for various problems in peer review. And this is something I'm going to talk about today. We also prove mathematical guarantees for many of the algorithms that we design. We also conduct insightful experiments in order to give proper evidence-based guidance towards designing peer review policies. And then we also help various stakeholders in real-world deployment of any of these algorithms for designing policies, etc. And our work has been used for peer review of tens of thousands of papers, and used for design of peer review policies in many venues. So today I'm going to talk about 5 categories of problems: reviewer mismatch, fraud, subjectivity, bias, and miscalibration. And I'm going to tell you a little bit about what we have been thinking about in these 5 directions, right? As I said again, please interrupt, ask lots of questions on chat, unmute yourself, raise hand, anything. So let's begin with reviewer mismatch. So assigning reviewers to papers is one of the most important parts of peer review. If you get a reviewer who has no clue what this paper is about, you are going to get a pretty crappy review. Right? And in computer science, peer review venues have, is there a question? Yeah, go ahead.
Oh, so I do have one question that you said there is a mismatch, that some people might not know the field very well, but sometimes like external people can bring new fresh ideas to the field. It's also possible. How do you guarantee that mismatch is definitely bad?
Well, good question. We don't guarantee that mismatch is bad, but this is what has been observed again and again and again, that in most cases, if there's like in highly technical papers, not general papers, these are highly technical papers, you need high technical expertise to understand and critique them. What you're saying is absolutely right. If you have papers that target a slightly more general audience, for example, if you have a survey paper, or there are these general journals like Science and Nature, where the audience is supposed to be more general. And that's where the perspective of an external person who's not in the field is very important. However, it's been seen many times that for highly technical content, like let's say you have something very intrinsic about the theory of deep learning, then you want somebody who understands deep learning and who understands math to be able to understand the paper. Great question. Other questions, please. Go ahead.
Thank you.
All right. Yeah, just ask questions, please. All right. So in computer science, the venues in peer review, which are mostly conferences, they have grown humongously. Okay? And there are tens of thousands of papers submitted. And so you can't manually assign reviewers to papers. So people have been working on designing automated assignment algorithms. And these algorithms operate in 2 phases. In the first phase, what you do is you take every paper and every potential reviewer. Okay, you have a pool of papers that are submitted. You have a pool of potential reviewers. So you take every paper reviewer pair and you compute what's called a similarity score between this paper and reviewer. So this score is a number, say between 0 and 1. And this is computed using various techniques like natural language processing, etc. And a higher value of the similarity score means that you envisage a better quality of review by this reviewer for this paper. Yeah. So we'll denote the similarity score between any paper P and any reviewer R as SPR. Any questions? Now, as I said, there are various techniques to compute these, many of which use natural language processing, and there are some references here. And now, once these similarity scores between every paper reviewer pair are computed, next what you do is you do the assignment. That is, you use the similarity score to assign reviewers to papers. So now what do popular algorithms do? They look to choose the assignment that maximize the total or average similarity score of the assigned paper reviewer pairs. So let me make this more formal in the next slide. So here is what they do, and they do this like commonly across most of computer science. So you have the similarity scores SPR for any paper P and reviewer R. Remember, higher is better. And they write down this optimization problem. So what is this optimization problem? Well, the variable of optimization is your assignment. So you want to choose the assignment that maximizes the objective on the slide. Now, what is this objective? You're summing over all papers and reviewers. And you have this SPR. This is the similarity between paper P and reviewer R. And then you have this indicator that paper P is assigned to reviewer R. Okay. And this is subject to the constraints that every paper gets, let's say, at least 3 reviewers, and no reviewer gets more than, say, 6 papers. Okay. And you also ensure that no paper is assigned to a conflicted reviewer. Okay. So overall, what this is doing is that subject to these constraints, it is choosing the assignment that maximizes the total or the average similarity of the assigned paper reviewer pairs. Any questions about this? Okay, please ask questions. So this is used very commonly across many venues. It's also used not just in computer science. Yes, question, go ahead, please.
I just had one question about the SPR score. I'm wondering, like, people can sort of, evolve their expertise, or, as there can be a temporal factor to this as well. So I'm wondering if that temporality is somewhere encoded in the score, or if it is discounted for this optimization purpose.
Yes, that's a great question, and that's a very good question. And what they do is that so today they'll compute these SPRs. So for you, if you are reviewer R, there'll be SPRs for you for all papers. And then 3 months later, there's another conference. And then looking at your record, then they'll recompute everything then. So your expertise evolves, and then these values are recomputed every some time that tries to capture your most recent expertise. In addition, there are other things like you as a reviewer, you may also be asked to provide your own inputs as to, hey, I think that this SPR that's computed for this paper is wrong. It's saying SPR is very high, but I have no idea about this paper, or vice versa. So you can also provide these inputs, and these are also incorporated in these SPRs. Yeah. Great question. Yes, another question, please.
Oh, sorry to ask another question. So like you are analyzed on the paper level, but you don't know which author do what. So it's unclear. Some people might do something very small or very specific. How do you know that he is the expert that to this paper, like to the next paper?
So the R is the reviewer. So what the way this is computed is like the text matching part takes the reviewer's profile. So if let's say you have published 20-30 papers, it will take your entire profile with all of the data, and using that it will compute this SPR. So for example, in one of the papers, it's so let's say your expertise is deep learning, but in one of the papers, you worked with a collaborator in biology to apply deep learning to biology, right? That'll just be one paper. And so it'll see that, hey, this is just one paper in these 20 papers, so we should give a very small weight to that. However, if it's out of 2019 of your papers are on biology, then it might think that, oh yeah, you're working on deep learning for biology.
I see. Okay, thank you.
Great. Other questions? All right. Awesome. So this is what's currently done. All right. So let's take a toy example about this optimization problem. And I'm going to ask you a question now. So let's say that you're running a small peer review setting, a toy setting, where you need one reviewer per paper and one paper per reviewer. And let's say these are the similarities SPRs. So on the row, we have the 3 reviewers. On the columns, you have 3 papers. Now, suppose you want to do what was done in the previous slide. That is, choose an assignment that maximizes the sum similarity. In that case, what assignment would that optimization problem choose? Can you think about it? Like, what assignment will maximize the sum similarities? You want to assign one paper to each reviewer, one reviewer to each paper, so that if you sum up the assigned SPRs, it's as large as possible.
So you're going to end up assigning on the diagonal reviewer 1A, 2B, C3, meaning you'll have, because that'll sum to 2, which is better than the sort of satisficing, I assume you're going to explain the better algorithm. But so basically you'll end up with great reviewers for paper A and B, and then just someone who has no idea what they're doing for C.
Thank you, Matthew.
If you do the maximum function.
Thank you, Matthew. This is perfect. So what it will do is it will choose the diagonal. And in choosing the diagonal, as you rightly pointed out, this assignment is kind of unfair to paper C, right? You're trying to maximize some sort of a global thing, but in doing that, you're putting a lot of weight in optimizing the reviewers for papers A and B, and then paper C is left out, right? You have a reviewer who has no idea about paper C. Right? So there is an alternate assignment here. For example, the one here shown in blue, where the total or the sum similarity is smaller. However, it's more balanced, right? Your papers A and B, yes, they don't get reviewers with a score of 1, you get scores of 0.7. But on the other hand, there's paper C, which gets 0.5. So a reviewer who might know something about paper C rather than nothing. Okay? Any questions about this? So this is a problem with the current systems, and I'll show you some plots also in a minute, but the current approaches can lead to these highly unbalanced assignments, and in practice they do. Okay. And this can be particularly unfair to interdisciplinary papers. So paper C often turns out to be an interdisciplinary paper. For example, the CVPR conference, which is the top computer vision conference with about 10,000-ish papers currently. This group, Copran et al., they looked at the data from there, and they found that using the approach that I just discussed, it assigns at least one paper and typically more papers, like all reviewers with very zero or very few similarities or very small similarities. Okay, so this does happen in practice. Whereas, as I'll show you in a minute, there are other assignments which are more balanced and they do better. Questions? Right. So in our work, we started looking at this problem, and we wanted to design assignments which are more balanced. So what we do is something like a modification to the earlier optimization problem. So what you see on the slide is what you saw 2 slides ago, with one key difference. The difference is in blue. So instead of considering a sum over all papers, now here this is considering the minimum over all papers. Okay. So you find the assignment such that the worst of paper has as good reviewers as possible. Okay, that's what this is doing. And now you recursively apply this. So you fix the assignment for the worst of paper, and then you remove that paper and then repeat this procedure for the remaining papers. Okay, so then you get as good as it possible reviewers for the next worst of papers, and then the next worst of paper, and so on. So in that manner, you're explicitly trying to create a much more balanced assignment. Solving this optimization problem is NP-hard in general. We propose an approximation algorithm with the strong approximation guarantees, strong statistical guarantees, and so on. Okay, so we also do a lot of theory proving guarantees, which I won't talk about here. Okay, any questions? And I'll show you some plots in the next slide, but any questions before that? All right, so here are some evaluations, and these are actually independent evaluations by Cobran et al. So the popular algorithms, as I said, they optimize the average or total similarity, whereas our algorithm tries to ensure balance or fairness. Now here, the x-axis is 3 venues. CVPR, that's a large computer vision conference, 2017 and 2018. And MIDL is a small workshop. Okay, so there are these 3 venues which Cobran et al. Evaluated. Now the y-axis considers the average or the total assignment similarity. Okay, so that's the value of the objective for the optimization problem in the initial slide. Sum over all reviewers and papers. Now the red bar is using popular algorithms which optimize the average similarity and have normalized to 1. And the blue bars are our algorithm which tries to make it more balanced. So we see that in terms of the average assignment similarity, our algorithm does somewhat close to popular algorithms. It achieves 90 to 95%, more than 95% in CVPR, which according to at least the program chairs, it's quite good. Like 5% reduction is okay as long as you get many more benefits. Now the plot on the right is the fairness. That is, how does the worst of paper fare? So here we have normalized our algorithm to 1, which is the blue line, because we optimize for this fairness metric. And the red algorithm are these popular algorithms which optimize average similarity. And you see that in CVPR 2017 and 2018, which are large venues, these popular algorithms perform really poorly. Okay, whereas in MIDL, they still do well on the fairness metric. So overall, we see that our algorithms, they do well in terms of fairness, which is not surprising since we are optimizing for that. But also they do quite well on the average assignment similarity. So you're kind of getting best of both worlds. Oops. Yeah, and now this is used, our algorithm is used in practice. It's implemented as well in conference management systems and so on. Okay, so before I move on to the next topic, any questions? Yeah, please go ahead.
So these might be very simple questions, but the first one I have is more about reviewing expertise. So somebody can have, very high reviewing expertise. Typically, like people who are earlier in their careers may not have, that much of reviewing experience. So is that how somehow sort of integrated into the optimization model, either in the, the scoring function or, in some other way? That is my first question.
Yeah,
and the
great question. Let me just answer that, and then we can move on to your second question, because I might forget the first one. Towards that, that's a great question. And typically there are various things that can be done. So one thing that is done in practice often is that if you have to assign 4 reviewers to every papers, you partition the reviewer into a junior group and senior group. And then you'll assign 2 reviewers from the junior group using this same procedure. And then you run this procedure on the senior group and assign 2 reviewers on the senior group. There are other ways you could do this, like incorporate this in the SPRs itself, etc. Great question. Yeah, your second question?
Yes, thank you so much for that. The second question I have is about reviewing style. So different people can, review differently. So I personally try to be very encouraging while also providing a lot of, actionable feedback and comments. Somebody can, be a little bit maybe authoritarian and, have a different way of writing their reviews.
Yeah.
And, I'm just wondering if this is something that is sort of considered. There are all these sort of talks about reviewer 2 being very hard and all of that. So I'm just wondering if this reviewing style is something that is also incorporated or considered.
Yeah, great point. Great point. So, this kind of falls under issues of subjectivity and miscalibration. For example, some reviewers are really strict and some are lenient, right? Or you as a reviewer might really emphasize on clarity that, hey, if there is a typo, I don't like it, whereas some others may not. And these are things that that are coming in the subsequent slides. But essentially at a high level, like we as a community do have a good handle on issues of subjectivity. That is, you put a different emphasis on clarity as compared to me and so on. However, for miscalibration, we don't yet have that great solutions. People have proposed solutions, they have tried them, they haven't really worked well. Okay. And the reason is small data, like very, very tiny data available. Yeah, I'll come to that. Hopefully I'll have time to get to that. But these are all wonderful questions and people have been thinking about these.
Thank you so much.
Great. Other questions? All right, if not, I'll move on. And the next topic I'll discuss is fraud. And there are two kinds of fraud I'm going to consider. One is called a lone wolf fraud. Yeah. So what does this mean? So consider peer review in competitive settings. For example, grant proposal review, where you have a fixed budget, or conference peer review in computer science, which are highly competitive and they have a fixed acceptance rate. 20% of papers will be accepted, 80% will be rejected, and so on. So now if you are an author who submitted a paper, and if you're also a reviewer for the conference, then you know what? Well, if you reject the other papers, it increases the chances of your own paper getting accepted. And this has been found to happen, and yeah, this has been discussed ad nauseum. There are some controlled experiments which have found this effect. Yeah. So this is what we call lone wolf. That is, the reviewer is acting on their own. And in this competitive setting, they'll try to manipulate the reviews of the papers they're reviewing in order to increase the chances of their own paper getting accepted. Okay, any questions about this issue? Okay. So now the question here is, how do we ensure that no reviewer can influence the decision of their own paper? Right? So this was the problem, right? That the reviewer is manipulating the reviews to increase chances of their own paper getting accepted. So now there is this method called the partition method, which is a really cute, simple method, which was proposed by Elan et al. More than a decade back, and has been studied widely, used in some cases primarily in studied primarily for peer grading. And what they do is the following. So consider the authorship graph that is shown here. That is, you have a set of authors who are also reviewers, and each author has authored one paper. Okay, so the edges are representing the authorships. Now, what this method will do is very simple. It will partition them into two groups. Now, it will assign the papers from the first group to the reviewers in the second group. It will assign papers in the second group to reviewers in the first group. Now, what you do is you only take the papers in the blue group, forget the red group, and just make decisions for the blue group. Assume the red group doesn't exist. Then you only take the red group, you forget the blue group, assume blue doesn't exist, only red exists, and make decisions for the red group. Question.
Oh, so I don't know how like computer science conference works, but my question is that does have different track and different track don't affect other tracks, something like this?
Could you say that again? Different. So it need not be different tracks. Like what you also want to do is have expertise, right? If the blue group is a track on deep learning, the red group is track on theory of something, right? Then you're asking theory people only to evaluate empirical stuff and vice versa. So you won't be splitting just by tracks because the expertise will significantly reduce.
Oh, my question is that how they know that they won't be affected? They maybe consider this is from another group of publications. Their how high is their score doesn't affect my score, or like that. That's my question.
Yes, yes. So I mean, so if you tell them, like if you show them this slide, then they'll understand that it won't affect. Right? Like if you show them this slide that, hey, you know, we're going to do this partitioning, 2 groups, red and blue, which are going to be evaluated independent of each other. Then they know that, hey, if I am an author in a blue group, if I am an author in the blue group, my paper is in the red group. Right? So if I'm an author in the blue group, I'm reviewing papers in the blue group, but my own paper is in the red group. And since the blue and red decisions are all independent of each other, my reviews affect only the blue group and not the red group. My paper is in the red group. Right? So if you just show them this slide, they know that, hey, I am going to review group of my color, but my paper is going to be in the group of a different color. And so my evaluations won't affect my paper.
I see. So they know this partitioning method, the reviewers.
That's correct.
Okay.
That's correct. So you should tell the reviewers that we are going to do this. Yeah. Great. Other questions? Yes, Eric.
Yeah, hi. And is the acceptance rate for the blue and the red similar?
That's correct. Yeah. So what you'll do is if you have a 20% acceptance rate, then you'll accept 20% from the blue and 20% from the red.
And so how do you define the group? So it reminds me of kind of conferences in sports. So if the blue group ends up being strong, so A and B are both very good papers, but you only take one, and the red group ends up being weaker, that kind of penalizes B just because of a random assignment to the group? Or how do you try to control for that?
Perfect. Perfect. So this is typically thought about for larger venues. For example, you have 1,000 papers and the division is random or semi-random. Yeah. So now because of this randomness, you can prove that with very high probability, the 2 sets are roughly equal in strength with overwhelmingly high probability. Great. Other questions? All right. So our work, well, what we do is I'll quickly talk about our work is, so peer grading has like 1-to-1 authorship graphs and so on. They're simple graphs, whereas we look at conference peer reviews where there are more complex authorship graphs. And then there's also this issue of similarities and expertise matching. And then the question that we ask is, can this partitioning method work for such peer review authorship graphs? And what we find is yes. And you know, it's promising to make it work, but we are not there yet. There's some more work to be done. Okay. And I'll keep this at a higher level for time constraints. Any other questions? Like my goal was to introduce you to the main problems here. So another kind of fraud is that of coalitions. And here, it's not just a lone wolf. There are multiple people, let's say these 2 people. And what they do is they'll make a plan. They'll say that, hey, why don't you bid on my paper? You try to get assigned my paper and give it a positive review. In return, I'll try to get assigned your grant proposal and give it a positive review and accept it. Okay. So they make this plan. Sometimes they make a plan to collude in the same venue and sometimes in different venues. And this is turning out to be a nightmare nowadays in computer science conferences. Okay. There have been many, many instances of where this issue has been found, but it's very, very hard to detect or prove something of this sort. And some of us are working on it, but it's essentially a very wide open problem on how to handle these kinds of collusions. Okay, any questions about this problem? Maybe one question for Daniel regarding the time. So I would try to make this interactive. So do you think I can just introduce the participants to a couple of other domains? It'll take about 3 minutes, and then we can open the floor.
Yeah, that sounds perfect.
Okay, perfect. So I'm very happy to go over the details of any of these in the discussions. But what I'll do now is just at a high level tell you what other problems people are thinking about. Yeah, that might spark some discussions. So another point is about subjectivity. So this has been discussed ad nauseum in the literature, much of which is in the social sciences, where different reviewers put different emphasis on the various criteria for judging a paper. So just as an example, there might be two reviewers, both of which agree that the paper has a lot of typos, but the content is great. One of them might say, hey, typos are okay, it doesn't matter much. Hey, let's give it a strong accept. The other one will say, hey, no, this has too many spelling mistakes. That's not acceptable. This is a strong reject. And people have found that this happens even if you give them guidelines and so on. So now what do you do about this problem? And this is something that we have been working on. So designing techniques based on machine learning, optimization, and social choice theory to understand these issues and to mitigate them. And the algorithms that we have defined have strong theoretical guarantees and have been used for reviewing many papers, for correcting issues of subjectivity in these reviews. Okay, so I'm happy to talk about this in the discussions. Another issue is that of bias. And this is something you might be familiar with. There have been many, many studies where people have found that a reviewer, if they see a famous researcher, they're much more inclined to hit accept. People have also found biases against certain groups like women and so on. And here there are questions about how do we test for these biases in any certain peer review venue? How do you mitigate these biases? And what are the various trade-offs in these mitigations? And these are the kinds of questions that we have been addressing. And the final topic is about miscalibration, and this was alluded to earlier. So there are multiple reviewers, and all of them might think that, hey, this is a moderately decent paper. However, there's one happy, jolly reviewer who says, oh, decent paper, yeah, fine, good, let's accept this, great job, authors, come on. And then there's other one who's grumpy cat who will be like, hey, this is only a decent paper. No, I have a very high bar. Sorry, this is a reject. You can't accept these kinds of papers. Right. So this is a problem of miscalibration. And there have been, as I said, there have been methods proposed for this. They have tried it in computer science conferences, but those methods have not worked well. A key reason is that you have very little data per reviewer and per paper. So each reviewer reviews just 3 or 4 papers, from which it's very hard to figure out if this reviewer is really, really strict or lenient, or is it just their opinion for this specific paper. Okay, so this is a wide open problem. And with that, I'll stop here. I've written a survey article about various AI techniques, etc. in peer review. If you're interested, you can feel free to look at this. I'll also type a link on the chat. With that, I'm very happy to open the floor for discussion. Happy to answer any questions about the things I could not get to as well.
Thank you so much, Nihar. Let's first give a round of applause. Very exciting research, very engaging presentation too. So thank you so much for that. So if there are any questions, please feel free to unmute yourself, shout, write, tweet, whatever you like.
Yeah, go ahead. Lizanne.
Thank you, Nihar. This is a very good presentation and very interesting work. So I have a question regarding the first project. Yeah. So it talked about biases in assigning reviewers. So are there survey or research work done in knowing the existence of a bias, or are those incidents totally anecdotal?
So are you talking about biases in the reviews, like
this one? The reviewer assignment, like
yes.
how?
Oh, the skew that you mentioned, like some papers got very poor reviewers and some others got much better reviewers. Is that what you're talking about?
Yes, I wonder if there are studies have done surveying authors saying that they actually are treated unequally.
Yeah, so two things. One, people have done measurements like what I'm showing you on this slide. So these are measurements on actual real world venues where they have found that the popular algorithms, they are highly skewed. So if you look at the fairness plot on the right-hand side, the red bars are for popular algorithms and they're very low for the two large conferences. Now, in terms of author surveys, so people have done author surveys with respect to the quality of the reviews. And the problem in trying to measure anything else is that the following. So they've found again and again and again, and this should not be surprising, that if the review is harsh, it recommends a reject, then the author is far more likely to say, hey, this was a crappy review. And if the review recommends accept, the author is far more likely to say, hey, this was a great review. Right? So the acceptance or the rejection given by the reviewer is a huge confounder and perhaps the primary signal in the response of authors to such surveys. Okay, did I answer your question? Did I understand it right?
Thank you so much. And I have another question.
Yeah, go ahead.
So there are a lot of questions about the whole peer review process, and there are a lot of suggestions given that not computational or like open peer review, or instead of giving guidelines to reviewers, just spend time and effort to train them. So what do you see would be the ideal model of peer reviewing for the future?
Yeah, that's a great question. I don't know about an ideal model, but we have been running various experiments to understand the effects of various things. For example, like reviewer training. So we ran a reviewer mentorship where I was a mentor for 50 reviewers, and we closely monitored their reviews versus those of the established researchers. And we found that with some mentoring guidance, the review quality was actually very good and comparable to more experienced people, and so on. So mentoring, yes, absolutely. Now, there are also various other studies evaluating the pros and cons and the trade-offs of various approaches. There are trade-offs in, for example, signed or open reviews. There are trade-offs in single blind versus double blind reviews, and so on. And I don't know if there is a perfect or ideal solution because there are trade-offs everywhere. But maybe just philosophically thinking, it's a good thing that, like, more generally, there's a lot of diversity. Some of it is open, some of it is closed, blah, blah, blah. So maybe, people can self-select into what they prefer or something. But overall, yeah, there are so many trade-offs that it's hard to define what you mean by ideal. There's a comment on the chat, oh, why minions? Say, minions are cute, right? No, they're fun. And another question, Subhashri?
Yes, thank you. I love the presentation and the talk. This might be a very basic question, but in my experience, something that I have seen is it's very hard to sort of estimate reviewing quality, whether it is good or bad. And it's not, it's not that the more experienced person will always give the best sort of review, especially, some of the things that I find is, time is a constraint for many people. So it could be that, somebody only reads one section, doesn't really see the whole thing as a story or the narrative that is evolving. So I'm wondering if there are any approaches to sort of, evaluating this, and, if there is a way or thought process of, how to maybe give people feedback on, what they're doing in the reviews and what can be done in the future. Just
that's a fantastic point. In fact, there is a very nice study, I think by Callahan et al., which tries to measure, which does the following. So that was in a certain journal where the editors, they evaluated review quality. Okay. And they considered that as a gold standard. They assumed that the editors know stuff, and they considered that as a gold standard. And now with that, they tried to see what is most predictive of high review quality. And is it the amount of expertise that, is it the seniority in terms of whether this is a professor or a student, etc.? Is this the number of publications subject to it being at least a certain number, and so on? And they find that all of what they tested were extremely weak or did not have any predictive power. So I absolutely agree with you that many of these criteria like seniority, etc., may not be good predictors of the review quality. Expertise, yes, because if you assign a math paper to somebody who doesn't understand math, things go away. But modulo that, seniority, etc., they're not predictive. And so that's a very interesting question as to what can be done. For example, like as was mentioned, maybe reviewer training and mentoring might make it better, and so on. Also, like another issue that you mentioned, and which is very good, is evaluating the reviews itself. In that study, they assume that, hey, the editor is somebody who knows everything and they have read the reviews carefully and so on, which is fine. In the venues that I work in, which is large AI machine learning venues, you don't have editors. You have what are called area chairs. So an area chair is responsible for handling a few dozen papers out of the 10,000 papers. And now the area chairs are usually asked to evaluate the quality of the reviews. Now there's a feeling in the community, and there's no evidence yet, but there's a feeling in the community that all of the problems that exist with reviewing of papers also come about in such reviewing of reviews. Some area chairs are very nice, like you pointed out, some are grumpy, and so on. And currently we are running an experiment in a large conference to understand these kinds of issues, that, hey, are these evaluations of reviews reliable at all? Or do they have these crazy confounding factors and other factors that are influencing them? Right? We don't know yet, but the experiment is actually currently going on.
Thank you so much.
Yeah, great question. Yeah, Shadi, you have a question? Go ahead, please.
Hi, thank you for the great presentation. I have a question about the bias part that you mentioned. There are different studies that show that like single blind reviewers and like, I don't know, like double blind can reduce bias, but also like in computer science, we see that most of the papers are on archive. So that has like another fact. So I was wondering if you have seen any evidence that like publishing on archive can bias reviewers, and how can we minimize that? Or what is the solution there?
Yeah,
thank you.
That's a great question. There are some studies which are more observational. That is, they say that, hey, these 3 papers were on archive and they got accepted, and these 3 papers were not on archive and they got rejected. However, those studies have a big problem that authors might have put their better papers up on archive, and papers which are not ready, they did not put on archive, right? So by definition, on archive were better papers and so on. So there are various issues with such kinds of studies. So I don't know of any study which establishes a causal link between putting on archive and increased acceptance. However, we have done some studies about the visibility of papers to authors. So for the papers which were there online when the review process was going on, what fraction of reviewers had actually seen these papers online? And how does this vary if this paper was from a top affiliation versus from a lower ranked affiliation? And what we found was, we did this in 2 venues, and we found that the visibility was lower than at least what I had expected. I think in one of them, it was about 10 to 15% of reviewers had seen it. And it was not very different across affiliations. There was some difference, but not so much. So that's one aspect about visibility. A second thing is that sometimes what reviewers might do, even in double blind, is that they'll search for the paper online, right? They'll Google the title of the paper online. And we did a survey of reviewers, anonymous survey, and about 1/3 of the reviewers self-reported doing this. So that's another issue, that even though people may not naturally discover the papers, they might search for the papers that are assigned to them. And yes, this might lead to these biases now. But yeah, I don't know of any causal link that has established this.
All right. So with that last answer and question, thank you so much, Nihar, again, for your great presentation.
Thank you.
Thank
you for the amazing questions.